Hey, Physics Boss Man back with you. A bat crashes into the vertical front of a subway train. If mu, the coefficient of friction, equals 0.83 between the bat and the train, what is the minimum acceleration of the train that will allow the bat to remain in place? This is like a road runner scene or something here, right? Train's going through the tunnel, hits the bat, and how much acceleration does the train need for the bat to stick to the side of the train and not to fall off? With God's help, you can do physics. Boss, as you are created.
You are created in God's image.
To be fruitful and multiply.
Fill the earth and subdue it.
Okay, to interpret the problem, we want to draw a picture. And I'm not a great artist, but I'll go ahead and draw the front of the train, and I'll just draw the bat more or less like a blob hitting the front. And so there's some acceleration of the train and the bat together, and that's the unknown. And so we go ahead and draw the forces here. We've got the force of gravity pulling down. That's what's going to tend to keep the bat that's what's going to want to pull the bat off the front of the train. We've got the force of friction, and that's what's going to tend to keep the bat in place. And then we've got the normal force, and the normal force is there, and that's going to help us figure out, because that's going to relate to friction. Okay, so the general principles involved are coefficient of friction, the other general principle involved is Newton's second law.
God has crowned you
with
glory and honor.
Honor to rule over his creation.
Okay,
so to develop our bullet point plan to solve this problem, we're going to make a free body diagram. And we're going to express each force. And I put my next bullet point too close. Need a little more room. In terms of mu, the mass of the bat, the acceleration of gravity, and so on. Now, some things will pop up in these problems that you might think you need but you weren't given, like the mass, right? What's the mass of the bat? We're not told. Hold your peace, just keep moving forward in the problem, put in the mass symbolically as the letter M, and there's a lot of physics problems where if you're not given the mass, you can put it in symbolically, and at some point sort of expect it's going to cancel out. And then we set the sum of the vertical forces equal to 0. And that's going to allow us to solve for the unknown coefficient of friction. All right, now to evaluate.
Science is a gift from God
to help us master nature.
But sin added thorns and thistles,
requiring the sweat of your brow to succeed. Now we're just carrying out this bullet point plan, and so our free body diagram was really the bat, right? So this is the bat, it's got a mass M, we've got the frictional force pushing up, because remember it's against the vertical surface, which is the front of the train. Got the force of gravity, minus mg, and then we've got the normal force sticking out from the train. And keep in mind that as the train's accelerating, the bat is also accelerating. And it's the normal force, the push from the front of the train, that's what is the force being applied to the bat to accelerate it in the positive x direction. So let's go ahead and clarify that our coordinate system is x in the direction of the train's motion, y in the vertical direction. All right, so I think that's all we need in terms of a free body diagram. Now we need to express each force in terms of the stuff we mentioned earlier. So the normal force, we mentioned, that's the force that's accelerating the bat. So from Newton's second, and it's the only force in the x direction. So from Newton's second law, the normal force is the mass of the bat times the acceleration of the bat, which is also the acceleration of the train because they're stuck together. Okay, now the gravitational force, well, we've already written down that one as mg, and then the force of friction. From the definition of the coefficient of friction, the force of friction is negative coefficient of friction times the normal force. All right, so now the force of friction plus the force of gravity equals 0. And where do we get this from? This also comes from Newton's second law, but Newton's second law applied to the vertical forces, or the forces in the y direction. This is the y equation of motion. The bat isn't falling off the front. Therefore, the vertical acceleration of the bat is 0. If the vertical acceleration of the bat wasn't 0, it wouldn't be stuck. It'd be falling off. That's where this equation comes from. So the force of friction in the upward direction needs to be equal and opposite the force of gravity in the downward direction. So this is our equation. Now substituting in minus mu times the normal force plus the force of gravity, which is minus mg, equals 0, minus mu, now the normal force is ma, minus mg equals 0.
Learning physics
Often requires prayer
as we submit
to Jesus Christ
as risen
King of Kings and Lord of Lords. Oh, we need to take a little care here. The normal force is upward, so this sign actually ends up to be positive just from reasoning that it's upward, so let's put it back in there as positive. So positive mu ma is the force of friction, negative mg, they cancel each other, so mu ma equals mg, so mu equals mg over ma. The mass now cancels out as we suspected it might, so it's g over a. Oh, but we need to solve for a here, so let's go ahead one more step. A equals g over mu, so it's the 9.8 meters per second squared over the mu, which is, what was it, 0.83? Now, it's important to note that coefficients of friction are dimensionless quantities, so they don't change the units, right? A force is equal to a force, so the coefficient of friction is unitless. Similarly, an acceleration is equal to an acceleration, so the units don't change. But when you do the numbers in there, the 9.8 divided by 0.83 is 11.8 meters per second squared. And that's what the acceleration of the train needs to be in the forward direction so that the bat doesn't fall off. Alright, so before we finish up here, we're going to go ahead and assess our answer.
We reign by surrender.
We reign by surrendering to Jesus and praying for our daily bread, which includes success
in our schoolwork.
God will answer and lighten our yoke and the impact of the thorns and thistles in our labor. So to assess, you think about three things: the units, and we thought about it, right? The units turn out as expected. The expression we got was g over mu, so the units of acceleration are the same as g, meters per second squared, which is what we were expecting. The sign, we are expecting that the train needs to accelerate in the positive direction, otherwise the bat wouldn't stick. That's kind of intuitive, but it did turn out to be positive. What about the magnitude? So does it make sense that in order to stick, the acceleration of the train actually has to be a little bigger than the acceleration of gravity? And yes, that does make sense. For something to stick to a vertical surface, the thing really does need to be moving along and accelerating quickly. So that makes sense. So this answer is correct.
Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Written in the Word, in the good, good Word is a message from our God. Gonna tell you all about how to get to the kingdom, the good life. Oh, I love Jesus. La 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 la.